James Kaufman, World News Report today. Ladies and gentlemen, we're in a heck of a geomagnetic storm currently. Now, we have solar winds upwards of 700 kilometers per hour currently, and we have plasma that's pushing pretty heavily on the planet. We did have a coronal mass ejection, or at least a solar flare that looked like it created a coronal mass ejection about 40 hours ago. If you'll remember the R2 radio blackout update I did, we've had no coronal holes that would create solar winds Earth facing for well over a week. So let's take a look at our KP indexes to start with. Our KP index is kind of a measurement of both our plasma and solar winds hitting the United States in different areas. We'll start out with Boulder. We see 9 hours of a G2 geomagnetic storm, 6 hours of a G1 geomagnetic storm, and 3 hours of a disturbance to start the day. We've been hot all day. All right, taking a look at our Fredericksburg KP index. Start out with a G1 geomagnetic storm, end up with a G2 geomagnetic storm. We've had a total of 12 hours of G1 geomagnetic storm, 3 hours of a G2 geomagnetic storm, and most recently we've had 3 hours of a geomagnetic disturbance. Looking at our estimated planetary index, our updated index that NOAA and NASA exclusively use, we started out the day with a G1 geomagnetic storm, moved into a G3 geomagnetic storm, back to a G2 geomagnetic storm, and we've been hanging on to that G1 geomagnetic storm level since that time period. Although I think that these are 5.67s, which would push these last 6 hours into a G2 geomagnetic storm, actually. Looking at the college KP index, started the day off with a geomagnetic disturbance, moved into a solid G2 geomagnetic storm for 6 hours, a G1 geomagnetic storm for the 3 hours following that, and then a G3 geomagnetic storm for 3 hours, and most recently we've had a G2 geomagnetic storm for the last 3 hours. Now I will show you that solar flare that looked like it lifted a small or light CME off the sun that had an Earth component that happened about 40 hours ago. That could be contributing to today's events, but yesterday was caused by what we call the Russell-McPherson effect, or the geomagnetic connection, and the poles turning south during the equinoxes, which happens, well, twice a year, obviously in March and September during the autumn and fall equinoxes. All right, we're going to go quickly here, guys. It looks like we actually did see that G2 5.67 for the last 6 hours on our estimated planetary KP index. And we did get up to a G3 geomagnetic storm, almost a G4 geomagnetic storm right there for 3 hours earlier today. Let's take a look at what that looks like. And NOAA did warn when we had the 3 hours of G3 geomagnetic storms. It says, what should you do? Monitor the Space Weather Prediction Center, which you'll see is completely wrong, and blew this whole thing up as usual. Terrible. So did their KP forecast. If you look at my last report, it says those under near the 30-minute predicted auroral extent may look for the aurora if at night and should weather conditions permit. We're already getting fried. Why would you want to go fry yourself some more outside? Again, this is their G3 strong geomagnetic storm. It is due to a coronal mass ejection influence, and we talked about that. I will show you that. But yesterday it wasn't. Yesterday it was just the Russell-McPherson effect, the geomagnetic connection during the equinoxes. That has, well, tilted our shills to the south, and that's allowing a very weak storm to really do damage to Earth. Hopefully y'all do watch the video all the way through and share it. Thank you very much. This is the event I was talking about right here. It was an M6.45. We had another M flare yesterday. Not as large of an event. I believe it was an M3.75-ish. That's not going to impact us until tomorrow if it does. This had an Earth component, and I mentioned it would because we got pounded by the X-rays on our D-region absorption prediction charts. Now today we've already had 3 M flares. 3 M flares. That's today. And we'll be looking at where those came from and what time those hit. But looks like the first one hit around 1 UTC time, which was about 8 p.m. last night Central Time. Looks like the next one was, and we'll get some better numbers, maybe an M2.45. And it looks like this happened about 9:30, so about 2:30 a.m. the morning. If you didn't sleep well, I understand. And then we got pounded by another M flare. Looks like an M1.83-ish. We'll get some exact numbers here. And that occurred around 12:30 UTC time, which would have been about 5:30 this morning Central Time. I give you all the Central Time so you can extrapolate your time period from that, obviously. If you're on the East Coast, you only subtract 7. If you're Central Time, you subtract 8. If you're Mountain Time, you subtract 9. Your West Coast, you subtract 10 from the, UTC time. Just a little lesson there. There's that flare that we're being affected by, that M6.45 that I mentioned, would have an Earth component to it. It was a light CME, but it doesn't matter because of the time of year it is. Today's big flare was a 268. Let's see what we've got here today. We started out with that M1.2 solar flare at a 4232. And since it's orange, we know that it was a beta gamma sunspot. Okay, beta gamma sunspot. And I said about 1. Well, it happened right about 1 UTC time, about 8 p.m. last night. Moving on, this is a delta sunspot, 4236. Although it hasn't done a thing. That's the most complex sunspot you can have. I see that 4230 is also now a Delta class sunspot. I did guess that both of those would become Delta class sunspots in my last report. Moving up to the next M flare, 4226, a simple sunspot group. We said 930, how about 940, an M2.68. Right about what we guessed. And again, that came from 4226. Now, so far we've had 4232, 4226, and now 4239 with an M1.8 at 1227. We said 1230, so we're doing pretty good here. Neither Delta sunspot got involved. Again, 32, 26, and 39. Currently, we have a 15% chance of having an X-class solar flare because of the 2 Delta sunspot groups. 6% chance of having an M-class solar flare. We've had 3 today. That ship has sailed. Been running a C baseline for months now. All right, over to HMI intensitygram, we have sunspot 4226 that just popped off an M flare, 4239 that popped off an M flare, and 4232, which is now a little bit more complex. It is now beta gamma. These are our 2 delta sunspots here, 4236, and 4230. What do we have a total of? 5, 8, 10, 11 sunspots with a couple that need to be named here, Earth facing. This could get ugly real quick with 4232 and 4236 coming into, well, firing position, if you will. Over to GOES 19 solar ultraviolet imager, 195 angstroms. It's just a busy beaver, folks. There's a lot that could happen and a lot that is happening. As you can see, any of these are capable of flaring. We saw 2 of the simple sunspots already produce M-class solar flares, and we have 11 total sunspots Earth facing as we look at this. We also have what looks like a coronal hole starting to be Earth facing, and that's going to throw another component into the mix. All right, if you'll look at my report from 40 hours ago, you'll see that, well, all was clear on the western front. They had the KP index at 1 or 2 for the next 3 days. That didn't happen, did it? Let's look at how bad they did over at the Space Weather Prediction Center. They did horribly. Today's the 30th. They have solar winds starting at 400, ending at 400. They started at 400, but they're above 700 right now. Terribly they did. Here we're moving up to plasma. They've got plasma here starting at around 8 and finishing the day up at around 5, give or take. Let's see what happened with that. That's a terrible call as well. We just paid millions of dollars to upgrade the system. I really don't know why any of these people are employed or why any of this is ever done. If they'll just give me the data, I'll do it for free. All right, over to our D region absorption prediction center. Our D region is the lowest level of our atmosphere, or the closest part of the atmosphere to Earth. Above that, there is an E1, E2, and an F1, F2, etc. That was the M1.2 flare, the last M flare that we just had. That was over the Atlantic. We haven't had one since, 9:30 this morning, I guess. So we're in good shape over the Americas, although everyone's getting a large dose of radiation. Don't worry, no worries. We're frying like eggs, like it or not. All right, this tells us that we have a southern component here. Everything's in pink here. This is bad news. That means just a little bit of space weather could affect us a lot. We have more than a little bit of space weather. There's a peak of 20.59, which is a decent peak, but we've got some peaks much higher than that. There's 38.45 plasma. This is all from that. This is the impact. This area right here, the impact from the CME, and that was over at about 11 UTC time, so about 5 a.m. this morning when we had that flare. It was about the time that CME was finished impacting Earth. Now, when that happened, we had solar winds kick in, and they went from 400, where they started. They got that part right? Now, they said from 8 to 5 on plasma. We went from, let's get this right. Went from 9, so the beginning wasn't bad, to 38.45 and some other readings. If we can grab them. It looks like I'm going to be able to grab too many of them. Plasma was, this is all missing. It won't let me grab anything in this hour area here, but this is when our CME was dying off. And then they had winds from 400 to 400, and here we are up over 700 to 726. Hard to explain because the CME hit here. It should have pushed the solar winds out in front of it, not behind the plasma, right? This could be the Kroll hole that's been Earth facing, but it sure would have moved fast if it is. Hard to explain here. No, but this should put us in a geomagnetic storm still, as they put down their next bar on the KP indexes. Temperatures have remained basically normal. And here's that CME impact right here. As you can see, it's over here. It last for several hours here. Let's see, from about 2 to about 11. So about 9 hours of impact here. You can see it. That's the plasma. Now, the solar wind should have been pushed in front of the plasma, but that's not what we're seeing happen. This is the solar wind starting at 400 and going up over 700, as we saw. This is our A satellite. The other was our Discover satellite. It's always good to check a few of them. Sometimes I'll even check the European or German satellite. Over to STO HMI magnetogram. Looks like a reverse polarity sunspot up here. It's one of the ones that is complex. Reverse polarity. When you're in the northern hemisphere, you should always have a white over black. White is positive, black is negative. In the southern hemisphere, black over white is correct. Northern hemisphere, white over black is correct. This looks like a reverse polarity sunspot. They always tell us that they're far and few between, but we see so many of them. And we can see that there are some sunspots that need to be named here. This was taken today at 1800 UTC. So this was just taken. Gives you an idea of exactly what we're looking at. We're most concerned with this area. Although, during the equinoxes, we have a huge geomagnetic connection to that departing limb. Please remember that. The Russell-McPherson effect. Alright, this was taken last night at 8:06 Central Time. I just don't think that those solar winds would have reached us. I would expect them in about 40 hours from now. They have not worked those in. These are our active sunspots. They're so close together, I don't know how they're really dividing them and naming them all, but they are. And these are the new sunspots, and these are the two that I showed y'all that need to be named very shortly here. So we should have an uptick in solar winds, although it's already over 700 kilometers per second, and we should have two new sunspots named by day's end, if not the start of the day tomorrow. All right, this is the Europeans, the ESA, Euphoria. It's the 30th and it's over. They have plasma in this area here from about 10 to 12. They did an alright job, although it did peak. They have it peaking the following day. So, you know, I would have thought that it would have moved a little bit slower too. I'm going to have to be honest about that. I don't know where they got this from. Look at this. That never happened, as far as we know. And then when you get down to solar winds, they completely blew it here. Watch for the 30th here. Going to be right about here. And they've got solar winds starting at 325 and ending the day way below 300 kilometers per second. So a total catastrophe. Now, I don't know where the solar winds came from either. I'm going to take a look at the back side of our planet right now because it makes no sense to me either. My forecast would have been similar to this one, I'm afraid. All right, I'd like to start by saying that there are a ton of solar winds and plasma hitting the bow here. But what we do have that's really strange is we have, well, cosmic winds, space winds, over 1.3 million miles an hour, moving in this direction positively. Here is Earth, this small little ball here. Obviously, it's turning 360 degrees counterclockwise every 24 hours. It's moving to the left at 67,000 miles an hour. It's being pulled at you by the sun at 525,000 miles an hour. Supposedly, the universe is expanding at 1.3 million miles an hour. A lot of factors. But with all those factors in play, and it moving off to the left at 67,000 miles an hour, these winds, when you run them through the scale here, come up to be moving up on it at 1.3 million miles an hour from behind the planet. See, they're off the scale here in blue. This is the plasma and solar winds hitting in front here. So we do have, well, another player in the house. We'll put it like that. Hopefully y'all stuck around. If y'all made it this far, let me know in the comments below. I'd love to know if anybody made it this far. We'll take a look at the planets and we'll be done with it. Alright, here is Earth. We have a geomagnetic connection of Pluto, Sirius, Saturn, Neptune, Eris, Uranus. This is a crazy area. Pretty good lineup right here. We have had some quakes. The moon is not really where it should be. If it was in front of or behind Earth, in between, it'd be even more so of a perfect situation as that moves anywhere through the, well, this part of our solar system with all the gas giants. We can expect more earthquakes than when we're over on the opposite side of the gas giants. For obvious reasons, the geomagnetics, the electric connections within the solar system on the side of the gas giants are on. They move so slow that they'll be over here next year when we get around to this area. They're all going to slowly move around. I believe Pluto takes over 900 Earth years to orbit one time, just to give you an idea. God bless, guys. Hopefully, y'all made it to the end. If you made it to the end, please let me know in the comments below. Say, I made it to the end, and I will kiss your butt. Imagine how long it took me to prepare this for you. Share, subscribe, and always remember, anything's possible in Bizarro World. God bless you all.